Okay, so we are continuing our lesson on logarithms. This is from Algebra 1. This is the logarithms lesson. And I'm picking up here with example 3 where we're learning to evaluate logs. I do want you to take note that this says you should be able to do these without a calculator. You will later in this chapter have a no calculator quiz over these logarithms. Okay, so probably most important thing is just to remember what we were just doing, where we were rewriting these things in exponential form, because rewriting them in exponential form helps you answer the question. So if I say I'm trying to figure out what this log base 2 of 8 equals, if this is like a question mark here, then really this statement becomes 2 to the power of what makes 8. Okay, if I circle this thing around, 2 to the power of what makes 8. And these are all the ones I'm going to give you in this section are ones that I expect you to know off the top of your head. So here we would say the answer to this thing, and I could be using an x if I was being more algebraic, should be 3, right? So in answer to that question, I would say log base 2 of 8 equals 3, okay? Because 2 to the third power makes 8. So for this next one, what I'm really asking myself is 5 to the power of what makes 1 over 25? So there's a couple of things I have to keep in mind here. First of all, to get from 5 to 25, I know that I'm going to be squaring. I know that I'm going to be doing a power of 2. But then we also have to think about how do we get this thing to flip over and become a 1 over 25? What kind of exponent does that? We do that using negative exponents, right? So if I put a negative 2 here, 5 to the power of negative 2 would flip this thing over and make it 1 over 25. So there's my answer. Okay, so be careful about how you're writing this next one. This next one is saying 64 to the power of what makes 8. Okay, not the other way around. 64 to the power of what thing over here would equal 8 as an answer. And so we need to think about what types of exponents make larger numbers smaller. We're not talking negatives. We're not talking reciprocals, right? But we're talking just taking a bigger number and breaking it down. Well, 8 is the square root of 64, right? So if I think about what exponent is really like a square root, that would be a 1/2. Now, if that's hard for you to think about, there's another option for you. There's another way you could kind of approach this one. You could look at this and say, okay, I can't figure it out going this way. I don't know what 64 to what power makes 8. So if I think about it as 8 to what power makes 64, and I can come up with a 2 to go right there, I know that because that's going from small to big, right? So if I'm going the other way around, big to small, it's going to be the reciprocal of that number. It's going to be 1 over that number there. Okay, so if you're stuck, that's a good way to do it. Okay, careful about doing this next one on gut instinct. This next one is probably the hardest question in this section. It says log base 9 of 27. So what you're really asking yourself is 9 to the power of what makes 27? And I did the box this time instead of a question mark just because I think that's going to look easier in a minute. And actually, maybe I'll just go and do real algebra and just call that x. So 9 to the power of what makes 27? There's not a direct power here, right? Because 9 to the first power would give me 9, but 9 squared would give me 81. Okay, so it's somewhere between 1 and 2. I do actually think this one works out to be 1.5, but I want you to be careful about assuming that it's right in the middle. It's not always going to be right in the middle. What I'm going to do here is I'm going to look at these things and I'm going to try to write them both as powers of the same number. I want to write them both with the same base. And so 9 and 27 are both powers of 3. So I'm going to take this 9 and I'm going to call it 3 squared. And I'm going to take this 27 and I'm going to call it 3 cubed. Okay? And so what that's going to do for me is here where I have 3 squared, but then I'm also raising to a power of x, I can combine those exponents by multiplying. So this becomes 3 to the power of 2x equals 3 to the power of 3 over here. And then I can look at these two things and say, well, now that these are both 3's, I know that my exponents have to be equal to each other. So I know that 2x must equal 3. So if 2x equals 3 and I'm solving for x, I can divide and I get 3 over 2. Okay, so my answer here would be 3 over 2 or 1.5. Okay, but that is a tricky one. That's one that you're probably not going to be able to do off the top of your head. It's going to take a little bit of work here. Okay, that next one doesn't even give me a real base to work with. This one just says b to the power of what makes 1. We kind of like this one because anything to the power of this magic number here equals 1. Magic number here would be 0. Anything to the power of 0 makes 1. Okay, so this is that log property that kind of says that same thing that we learned about 0 exponents. Okay, this next one is one of the easiest problems in this section, and it should be, and I hope that every time you see one of these, you recognize it for being as easy as it really is. Here's what this question is saying, and I would leave this 3 to the 5th power alone. I would not try to evaluate like what 3 to the 5th power is, especially if I don't have a calculator, okay? This question, again, if I loop this thing around and have this be like my question mark over here, is saying 3 to the power of what equals 3 to the power of 5. Okay, well, look at that for a second. What's the question mark have to be? Kind of just like when we looked up here and we said 2x has to equal 3. Here we have that this thing must be equal to 5 because these are both bases of 3. So my answer here is just 5. Okay, and that leads us to kind of an important property too, that anytime I do log base something and then this number matches, so anytime these two numbers are the same, if you have an exponent up here, the answer is always just going to be that exponent. Because you're going to run into a similar situation like this. It's b to the power of what equals this thing here. Okay, and that answer would just be the exponent. Okay, so again, I'm going to pause it here, give you a minute to catch up if you need to. I'm going to give you a couple of practice problems to try with these, and then we'll move on to example 4.